Hello dear viewers, my name is Mislav. I will be presenting the solution on behalf of my team, arTISts, made for this AI in Healthcare Hackathon. First, we will describe the challenge. Then we'll overview our plan and our approach. Then we'll demonstrate the technical side of things and wrap it all up with the conclusion. The challenge we decided to pursue was challenge number 3 in AI applied to medical imaging track. This challenge concerned itself with calculating the cobb angles of scoliosis in coronal radiographs. We were provided with the train and test dataset of coronal radiographs and the landmarks for the train dataset. We were then asked to calculate the maximum cobb angle for each radiograph in the test set. Our hackathon plan was composed of modifying our annotation app, arTISts, to work well with radiograph images, creating a neural network in PyTorch trained on the provided data to get the landmarks for all the upper and lower points of thoracolumbar vertebrae, creating a Python script to calculate the cobb angle using the landmarks that we got from the neural network, and creating a platform for measuring the cobb angle. During this hackathon, we managed to do everything except the last point. Our tech stack included PyTorch, Python, and Microsoft Azure for training the neural network. You can see the specification of the virtual machine listed here. We have experience with various types of applications for annotation: computer vision annotation tool, SuperAnnotate, and most recently, our own application, this annotation tool. We made the annotation process as simple as clicking on the landmark on the image and assigning it a label. We can easily process the annotated data because it is saved conveniently in JSON files. It supports the widely used COCO data format. Now we can see this annotation tool in action. Notice how easy it is to add landmarks to the image. When training the neural network for landmarks prediction, we have done the usual stuff, which includes custom data loading and custom data transformations necessary for this dataset, training loop with train and validation split, and rescaling the landmarks to the original image dimensions after they exit the network after inference. We use transfer learning. Although there's a paper which suggested that no significant improvements were made by using transfer learning, we found the neural network to perform slightly better than by not using transfer learning. To achieve this, we stacked the image's grayscale layer 3 times in order to obtain the RGB image the model required. We could also try image augmentations as our next potential improvement. Here we can see the neural network outputs on test images. The landmarks are the red dots. Note that these examples weren't cherry-picked. We had to calculate the cobb angle ourselves since the MATLAB script provided in the dataset was faulty. We calculated the angle between the upper points of one vertebrae and the lower points of all the other vertebrae. We only kept the largest angle. If you want to see our implementation of the cobb angle calculation, or of anything related to this hackathon, take a look at the GitHub repository we provided. All the resources related to this hackathon are there. In conclusion, our solution is useful for diagnosing the cobb angle from radiograph images of scoliosis patients. It can be implemented in almost every orthopedic clinic. You can see our team on the right. This is us. We want to thank you for the opportunity to present our AI team and the way we solve problems. We would also suggest that you check out our current AI in Healthcare project, SEND, which stands for System for Early Neurological Deviation Detection. Best regards.